What's up guys, welcome back to my channel and enjoy your stay. And in this video, let's talk about the actual implementation of SAMuC project when it is already installed in the amplifier enclosure like this one. If this is your first time to hear SAMuC, it's actually my personal project in controlling DIY amplifier to manage in terms of power management, speaker protection, and heat dissipation, especially for Class A or Class AB type amplifier. And the SAMuC is run by an Intel 8051 high-speed microcontroller with a dedicated firmware made using Bascom language. Actually, SAMuC stands for Smart Amplifier Manager using microcontroller. You know guys, I'm actually teaching the art of programming the 8051 micro for our audio hobbyists. Check out my tutorial guys. Let's take a look at it. The SAMuC board already installed into the mini aluminum casing that is 20 by 5 by 30 cm. It's actually small and there is no heat sink. The whole case will gotta be the heat sink. And having said that, let's put a test case to see if it's functioning well. It's gonna be like a simulation test close to the real world scenario. In the earlier video, I published a bring up test in the PCBA level. You might like to see that video. Just click the link on the description below. Let's see the power management. One of the main features of the SAMuC is to automatically turn off the amplifier after a predetermined active mode that is selectable in 30 minutes or 60 minutes. Actually, this feature is good if you use the amplifier at bedtime. In this case, it will put the amplifier into deep sleep mode to reduce the amplifier power consumption. That means it totally cut off the supply voltage of the amplifier, making the system power consumption to be less than 1 watt. That is inclusive to the echo mode. The echo mode idea in my reading is about 0.7 watt or about 700 milliwatt. With the man-machine interface on the front panel, there is a switch there that you can select either a 30 minutes sleep time or 60 minutes sleep time. And you press once or press 1 second. This means it will goes into the 30 minutes sleep time. And if you're gonna press 2 to 3 seconds, then it goes into the 60 minutes sleep time. And when the auto turn off engage, the LED will blink fast, which means 30 minutes, and slow blinking LED will means 60 seconds. This is how the man-machine interface is created. The speaker delay or mute. The sequence of the voltage supply to the amplifier against connecting the speaker is about 6 seconds delay in the power on. This is shown to make it sure that the noise probably generated in the amplifier when you apply the DC voltage will be eliminated. And also in the power down mode, the speaker will be disconnected first, then disconnect the supply voltage. In this way, whatever is happening in the amplifier like oscillation or tick or thump noise will not be heard on the speaker during the power on or power off mode. A DC voltage appearing at the speaker terminal will damage the speaker. This will happen when the amplifier is overdriven or when the output signal is being clipped that will produce a DC voltage component. And you know, guys, the worst case is that when the output stage will get burned, and it is possible that the plus or negative full supply rail will appear on the speaker. That will definitely burn your expensive speakers. But with the use of a dedicated IC like the C1237H chipset, it can detect about plus or minus 0.85 BDC or higher, and it will going to remove the speaker from the amplifier via the relay, and in this way the speaker will always be protected. When the amplifier is active, and assuming the output powertrain is suddenly damaged due to substandard output transistors, say for example, the high DC offset will be sensed and immediately remove the supply voltage. It goes into the protect mode for, let's say, about 30 seconds, and this time you cannot power on the amplifier. It will go directly into the standby mode. Actually, when you power on the amplifier and there is a high DC offset voltage, the microcontroller will check first if there is any DC output from the amplifier, and if so, it will never connect the speaker to the amplifier. It's always remove the power supply via the relay, and it goes into the standby mode. For Class A or Class AB amplifier, the SAMuC will check the temperature, and I mean the heatsink temperature. And let's say if the heatsink surface temperature reaches about 45 degrees or higher, it will turn on the fan automatically. This is a kind of simulation I'm doing right now because I don't have yet the amplifier installed into my aluminum case. Well, manually, you can also force to turn on or turn off the fan using the switch on the front panel. When the aluminum case or heatsink temperature goes 75 degrees or above, it will going to turn off the system, the AC power, as well as the speaker. It will going to prevent the amplifier from a possible thermal runaway of the output stage or possible get burned. Though the logic shows that the fan already turned on automatically at 45 degrees, and the amplifier still generate a lot of heat, let's say at maximum power or maximum volume, then it going to reach like 75 degrees like the simulation. And when you reach that 75 degrees, it will shut down the whole system. This is the fail-safe of the SAMuC. For the schematic diagram of the SAMuC, I put it, you can find it actually on the download link below. I also share the firmware, which is about 2K bytes. It's actually within the Pascom 8051 IDE demo version with a maximum of 4K bytes. Should you decide to modify the program, let me know if you would like to have the source code as well as the other documentation of this project. Well, that's the end of our video for SAMuC amplifier casing demo. And if you like similar videos in DIY amplifier stuff, kindly consider to support my activities by subscribing to my channel, sign into your Google account, and click the subscribe button. Share it to your DIY friends who love DIY and learning audio stuff. And bye for now, and see you in the next video. Stay tuned, guys.